Bismillahirrahmanirrahim. Good morning, everyone. Today we'll talk about the periodic table, the second lesson in Unit 3. After understanding about the atom and the particles that make up the atoms, which are protons, neutrons, and electrons, after understanding what is the atomic number, what is the mass number, we are going to study about the periodic table. What is the periodic table? The periodic table is a table that contains all the elements, all the discovered elements in the world up to now. They are arranged in a pattern. We will see how they are arranged. So it is not only a list of all the elements randomly arranged. No, they are arranged depending on a rule. We will see what is this pattern, how they are arranged. We will talk some about the history of this periodic table, who was the first one who started putting this periodic table, how it was developed until it becomes like the one that is in front of us. Okay, let's start from the beginning. They said to us here that first in the very ancient ages, they said that all the world is made of four materials only, which are the fire, wind, earth, and the water only. This is what they thought before. Later, for sure, these thoughts were developed, and the chemists discovered about the elements, they discovered about the atoms, and finally they discovered about 60 different basic substances. For sure now, what are the elements that are known? They are about 118 elements. But before, when the chemists started, they were talking about 60 different elements. Later, a chemist called Dmitry Mendeleev thought about arranging these elements in a table. So what did he do? He wrote all the names of the elements on cards, with writing every atom's mass, every atomic mass on this card. Then he set them in order, in the order of the atomic mass. Okay, what did he do? He wrote the names of the elements on each card, each element's name with the atomic mass. What is the atomic mass? We learned in the last lesson the mass number. The mass number, we said it is the sum of neutrons and protons. But here, the atomic mass, let's see here, the atomic mass, this number that is below the word aluminum, is the atomic mass of the aluminum. What is it? It's okay. I'm going ahead. I'm talking about something in advance, because you have to understand what is the atomic mass. The atomic mass is not only the mass number. Here, as you see, it is a 26 point. From where this point it comes? Because the aluminum can have many isotopes. What are the isotopes, girls? Remember, what are the isotopes from the last lesson? The isotopes that some elements can have different number of neutrons in the atoms that make up the element. All the elements are having the same number of protons and electrons, but the number of neutrons can be different, and we call the elements the atoms of the element that have different number of neutrons, we call them isotopes. So aluminum can have isotopes. So some aluminum atoms can have 26. The mass number can be 26. Some other atoms 27. Some other they have more protons, more neutrons. So the mass number is 27. Others 28, others 25. So finally, which one of them we will take its atomic mass? Which one? They take the average. The average. How? They will add like this. Let's see. It means they take the average of all these isotopes, the average mass of all of the isotopes. How? Like this. Let's say 25 plus 26 plus 27 plus 28. Finally, the final number is what? It will be divided by how many? 1, 2, 3, 4 by 4. Let's see what is the number. So I find 26, 25 plus 26 plus 27 plus 28. The answer was 106. 106, it has to be divided by 1, 2, 3, 4. The 4 isotopes divided by 4, it will be 26.5. This is an example, but maybe here, because they found it 26.98, that means there are more isotopes, or maybe the isotopes are not exactly like what I found. So finally they put for us what is the final number of the average mass of all of the isotopes. This is the atomic mass. Let's go back now to the periodic table, how it started. We said the periodic table was set first by Mendeleev. He depended on the atomic mass, and we explained now what is the atomic mass. He depended on the atomic mass by the increasing of the atomic mass. He started from the least mass to the greatest mass. He put them in a table. Then this table was named the periodic table. After Mendeleev, a chemist called Moseley developed the periodic table. Here is Henry Moseley rearranged or reorganized Mendeleev's periodic table. He put the elements in the increasing by the order of the increasing number of protons, or the atomic number, which was better. Why? Because the atomic number here is fixed for every element. It doesn't change There is no need to find the average or something like that. It is stable. Every element has the same atomic number for all of the atoms. So it is stable, which was better for the periodic table. The periodic table is useful because it makes it clear for many patterns among the elements' properties. So they depend on the periodic table for studying the elements' properties. Let's go now. As you see here in the periodic table, they put in order from the hydrogen, which is the first one, to the end. The atomic number is increasing. As you see, hydrogen, the atomic number is 1. Helium, it's 2. And the next, lithium, 3. Beryllium, 4. Boron, it's 5. Carbon, 6. Nitrogen, 7, and so on, up to 10 in neon. Then in the third line, 11, 12, and like this. Okay, done. Now, let's start from now knowing about the periodic table. Every line, every row is called a period. So starting from up, period 1, period 2, period 3, period 4, period 5, period 6, period 7. The last 2 lines, they are included in period 6 and in period 7. Look, they have to be in this space here. Why they are separated? Because if they were included here, the periodic table will be very, very wide. It can't be in one. It can't be included in a paper, in a book. So it will be very difficult. So they prefer to take these 2 groups aside. Okay, now periods are the lines or the rows. But what about the vertical columns? The vertical columns are groups. So group 1, group 2, group 3, 4, 5, up to 13, 14, 15, 16, 17, 18. It has 18 groups. 18 groups. Every one group, all the elements have very similar properties. So they can be in one family. So the group can be called also family. Okay, now let's talk about every square in this periodic table. Actually, every square is made or contains in the middle in bold line the symbol of the name of the element, as what you see here, AL. A in capital or a capital letter, and L in lowercase or in small letter. This is the chemical symbol. Okay, now why Al for aluminum? They actually, you will see that some elements, oh my god, sorry, some elements have the symbol of one letter, like K for potassium, C for carbon for example, boron B, oxygen O, nitrogen N. Some other elements, they have two letters. Why? Mostly because they have to be distinguished from others. For example, here we have boron and we have brom. Here, this one in the red, brom. Both, they start in B. So to distinguish them from each other, brom has two letters, B and R. Even some in the end of or in the lines at the end, some are having three letters, especially these that are in light writing. These that are in light writing, they are not discovered yet. They are not found yet. They are discovered they have to be discovered, but they are not studied yet. Okay. The under the symbol, also the symbols, under the symbol is the element name. Some names, they are identical with the common names, like aluminum, Al for aluminum, it's the same. They can be the same as the symbols. Some are not, like here, for example, in potassium, K. You see that potassium here. Potassium is in P, but the symbol is K. Why? Because they take it from the Latin name, not from the English name. Okay, that's it. Let's go back to aluminum here. So this is the chemical symbol. Under it, the element name. Then what is in the top, the number that is in the top is the atomic number. Again, what is the atomic number? It is the number of the protons, which is stable for every element. It is the same. Down, the average atomic mass. What is it? I explained it already. It is not the mass number, not exactly the same as the mass number. The mass number is the mass number is the sum of protons and neutrons. While here it is not exactly what is it? It is the average atomic mass of all the isotopes. Okay, so here the aluminum, it has 13 protons, as you see. Okay, it can have 13 neutrons too. It can have 14 neutrons. It can have 15 neutrons. It can have 16, for example, neutrons. Okay, so if we take the sum of the atomic mass for this, the mass number, then we add them together all, then we divide them by 4, for example, we will get, or maybe there are more isotopes or less isotopes, we will get finally this number. That's it. This is for the atomic mass, the average atomic mass. I hope this was clear. I gave you here the highlight for what you have to study. Then let's leave the rest for tomorrow, inshallah. We will talk mostly this lesson here. What we will take it tomorrow, we talk about it. You can read it. They will talk about metals, non-metals, and metalloids, which we take, alhamdulillah, in the last unit. Okay, so the next period will not be about something new. We will talk about metals, metalloids, and non-metals. Then we will explain about the groups. We will explain about the periods in more details, and we will be done from this lesson. I hope this was enough for today. If you have any questions, send me during the time of the school, please. Okay, thank you.